Alright class, today we're going to go over the types of chemical bonds. We have ionic bonds, covalent bonds, and metallic bonds. So you see the picture on the left, I took a picture of Bond, James Bond. You might remember some of those movies in the past and recently actually. This will help us remember the types of bonds. First, let's look at how chemical bonds actually form. Remember, in your chemical bonds, in any atoms, your protons and your neutrons stay in your nucleus, but the electrons could transfer or share between atoms. So here on the left I have a metal, let's say lithium, and I'm going to have one valence electron because it's in group 1. And let's combine that with a non-metal, let's say chlorine. There I have group 17, count the last digit, 5, 6, it will be 7 valence electrons. The whole goal for atoms is to get to a full valence shell, also called the octet rule. Oct means 8, like 8 legs in an octopus. So right now the metal has 1 electron on the outside, the nonmetal has 7. The metal electron is going to transfer over to the nonmetal. By doing that, the nonmetal obviously has 7 plus the extra 1, which would be 8, and that would be a full valence shell. The metal would have a full valence shell in the previous energy level because electrons always want to go from low to high energy. So that's the generalization of how a chemical bond works in an ionic bond. Definition of an ionic bond is, again, it's a bond formed between two ions by the transfer of electrons. Electrons are going from the metal to the non-metal. Good way to remember ionic bond, it has to be a metal with a non-metal. Okay, metals on the left side of the periodic table, non-metals are on the right. In an ionic bond, again, you have metals and non-metals. They have very different electronegativities. Electronegativity is the tendency for atoms to pull in electrons. So what you could do is take the difference of your two atoms. If the electronegativity is big enough, typically over 2.5, you will have a ionic bond. Again, they're formed by the transfer of electrons. They go from the metal to the non-metal. They produce charged ions all the time. The lithium, remember lithium lost an electron, so Li lost an electron. If you get rid of something bad in your life, it'll be a positive or a good thing. Li will have a +1 charge. The non-metal, in this case the chlorine, gained an electron. If you take in something bad in your life, that's a bad thing. Chlorine will be a -1 charge. Some examples are NaCl, that's just table salt, calcium chloride, potassium oxide, for instance. Good way to remember ionic bonds, think of one big greedy thief dog. Here I have my chlorine, who's the greedy thief. He wants to take the bone. You have this weak dog over here, the metal is your sodium. The greedy thief dog takes the electron from your sodium to your chlorine. Now, other times you'll have what's called a covalent bond. In a covalent bond, you're going to have electrons that are shared between them. So let's look at H2O, that's hydrogen dioxide or water. Hydrogen has 1 valence electron. So here you have 1 electron. Since I have 2 of them, I'll draw another hydrogen. Let's make it the same color. Here's another hydrogen, another valence electron. And then oxygen, if you look up oxygen, it has 6 valence electrons. So obviously oxygen needs to get 2 more to get to 8 to fulfill the octet rule. Hydrogen's in group 1, it's also in period 1, so you only need 2 electrons for hydrogen to make a full valence shell. Now instead of hydrogen transferring the electron between the oxygen, we're going to have a sharing of electrons. So one of the electrons of oxygen is going to combine and share with one of the electrons in hydrogen. By doing that, the hydrogen will now have 2. This hydrogen and this oxygen will also share another electron, and by doing that we will have hydrogen on the left to be full of 2, Oxygen sharing 2 electrons, so 6 plus the 2 more also equal 8. Again, a covalent bond is a bond formed by the sharing of electrons. Electrons can be shared between 2 atoms. The way to figure out if a bond is ionic or covalent is you want to see if there are 2 non-metals. Remember, your non-metals are on the right side of your periodic table. They'll also have similar electronegativity. That's the tendency to pull in electrons. Some might have more electronegativity than others, like fluorine will be greater than, say, carbon, but they both want to pull in electrons. And they're formed by sharing electron pairs. They have stable non-ionizing particles, meaning they do not conduct electricity, such as an ionic bond that does, like NaCl. They are not conductors at any state. Some examples, again, think about the non-metals. O2, carbon dioxide, C2H6, it's a hydrocarbon, water, silicon with carbon. Those are all examples of covalent bonds. You'll be asked to determine if a compound is ionic or covalent. Look at where your atoms are located. Again, metal and non-metal means it's ionic. 2 non-metals means it's covalent. You could have 2 different types of covalent bonds. One's called a polar covalent bond. That's when they're unevenly matched. One has a bigger electronegativity than the other, but they're willing to share. So on the left, let's say I have a carbon atom, and on the right I have the fluorine atom. Fluorine is the most electronegative of all the elements. It's on the top right of the periodic table. Carbon is still fairly high in electronegativity, so they're going to share the electron. It'll be somewhere in the middle, but it'll actually be slightly closer to the fluorine. It's like a slightly tougher dog than the carbon is. So again, they're sharing the electron, but it's uneven sharing. You could also have a non-polar covalent. That's when you have the exact 2 elements twice, like O2. Obviously, one oxygen is not going to be stronger than the other oxygen, so they're going to equally take in their electrons. Last type of bond you'll have is what's called a metallic bond. That's when you combine 2 metals together. They're typically transition metals. That's in the middle of your periodic table. They hold metal atoms together very strongly. Metallic bonds, think of alloys for brass instruments, for instance, like a trumpet. Very hard to destroy the bonds between them. Here's a metallic bond, which you have a sea of electrons floating around the metals. Sometimes they also call it an ionic bond, but again, if you have 2 metals, it's a metallic bond. Here you see the red circles are floating electrons in a sea of metals. So there you have the 3 different types of bonds, the ionic, covalent, and metallic. If you have any questions, feel free to send me an email, kaminskyl@hayescisd.net.